Hi everyone, here is our math problem for today. This is a math Olympiad question. We are asked to solve for a, where a is an element of the set of real numbers given this equation. 2 raised to a plus 2 raised to 3a equals 10. You can pause the video and see if you can solve this math Olympiad question. Now let's solve this problem together. The first thing that we are going to do is we are going to rewrite our given equation to make it look more simple. And we can accomplish that by doing substitution. So we let the value of the expression 2 raised to a be equal to certain variable x. And then based on this substitution, we can now express the second term 2 raised to 3a as the quantity 2 raised to a all raised to 3 using the inverse of the power law of exponent. Because when you have the quantity 2 raised to a all raised to the third, we can apply the power law of exponent by copying the base 2 and multiplying the exponents a and 3 to get 3a. So the first term 2 raised to a is now x. The second term 2 raised to 3a is now therefore equal to x cubed because 2 raised to a is equal to x, and we just copy the exponent 3. With this as our substitution, we can now rewrite the original given equation as x plus x cubed equals 10, where x is equal to 2 raised to a and x cubed is equal to 2 raised to 3a. Next, let's rewrite this equation in descending order of power and making the right side equal to 0 by subtracting 10 from both sides of the equation, and this is now our result. This is a cubic equation, and we expect to get 3 roots. And those 3 roots could be a combination of real and imaginary roots. But in this problem, we are only after the real values of a. So there are several ways of solving this problem. One is using synthetic division in order to apply the rational root theorem, or we can use trial and error, or we can use factoring by grouping. By inspection, looking at the original equation, one can easily see that if you let a be equal to 1, then you will arrive at a correct equation because 2 raised to 1 is 2, 3 times 1 is 3, and 2 raised to 3 is 8, 2 plus 8 is equal to 10. But since this is a math Olympiad question, we cannot just simply assign value for a and claim that that is the solution. Also, even if you know that a equals 1 can be one of those solutions, notice that we are expecting here 3 roots. We are not just sure whether those 3 roots are all real numbers or a combination of real and imaginary roots. So in this case, let's use factoring by grouping. And we can accomplish that by rewriting this x as sum or difference of 2 terms in such a way that we can come up with common factors when we perform factoring by grouping. So in this case, we are going to rewrite x as 5x minus 4x because anyway, 5x minus 4x is indeed equal to x. The choice of this is because we have a constant 10, and the 5 and 5x will give us a common factor 5 when we perform factoring by grouping. So let's rearrange this also this way. First, we split x cubed as product of x and x squared, and then we rewrite 5x minus 4x as minus 4x plus 5x. Now, 5 is common between 5x and negative 10. X is common between x times x squared and 4x. So let's factor out those common factors. But first, we need to group together the first 2 terms and the last 2 terms this way. Then, factoring out now the common factor x and the common factor 5, we arrive at this. Notice that we have here difference of 2 squares because 4 is also a perfect square. And we can factor this out as the product of the sum and difference of the square root of x squared and the square root of 4, which is 2. So the result is this. Copy x, factor x squared minus 4x as the product of x plus 2 times x minus 2, and copy all the rest. From here, notice that the quantity x minus 2 is common between the first term and the second term. Here we have 2 terms separated by the plus sign. This is the plus sign. This entire expression to the left of this plus sign is considered as one factor. This expression to the right of this plus sign is our second term. So factoring out now the quantity x minus 2, this is the result. So x minus 2 is here. When you divide the first term by x minus 2, the result is x times the quantity x plus 2. When you divide the second term by x minus 2, the result is simply 5, and we copy the right side. Now let's simplify the second factor here. We copy x minus 2 and simplify the second factor to arrive at x squared plus 2x plus 5. And we now have these factors whose product is 0, which implies that x minus 2 could be 0, or x squared plus 2x plus 5 is also 0. In order to get a product of 0, at least one of the factors must be 0. Now, let's solve first the first case. X minus 2 equals 0. Adding 2 to both sides of this equation, we arrive at x equals 2. And since x is equal to 2 raised to a, then we now have this equation 2 raised to a equals 2. Any number is implied to have an exponent of 1. And so we can write this further as 2 raised to a equals 2 raised to 1. When you have two equal exponential numbers with the same base, then their exponents must be equal. And so we now confirm that a indeed is equal to 1. And this is one of those three roots that we are looking for. Now, where are the other two roots? That would be in this quadratic equation, x squared plus 2x plus 5 equals 0. So let's solve this quadratic equation for x. Let's use this quadratic formula, and substituting the values for a, b, and c, we arrive at this result. And simplifying, we have negative 2 plus or minus, this 2 squared is 4, negative 4 times 1 times 5 is negative 20, then all over 2. 4 minus 20 is negative 16, and so we arrive at an imaginary number here. The square root of negative 16 is equal to 4i. Copy all the rest, and simplifying, we have now this result. Negative 2 over 2 is negative 1, plus or minus is copied. 4i divided by 2 is 2i, which is clearly not a real number. And since our a here is required to be an element of the set of real numbers, then negative 1 plus or minus 2i, although these are roots of the given equation, will not be accepted as the answer to this problem because of this restriction. A must be a real number. And so for our final answer, the value of a is a equals 1, which confirms what we already thought to be the value of a. But in mathematics, we cannot simply assume the value until we show mathematically that that is really the answer, especially for Math Olympiad contest where this problem was taken from. So thank you very much, and we hope to see you again in our next video. Bye for now.